Hi, I'm Paqueta12 and today we build a particle system from scratch. And we play with trails, directions, angles, and also we build this surface on each particle to achieve this 3D look. What is a particle system? Um, it's a group of points in space guiding by a collection of rules or forces. You can do fire, galaxies, explosions, air particles, but here they also said particle systems are frequently written from scratch if non-standard effects or behaviors are desired. And we don't want standard effects, and so let's build this crazy system and play with it. So let me close this. Okay, and start from scratch. We need a constant chop, so constant chop, and here let's set the resolution. The resolution X, let's go with this, so 1280 ratio. Okay, the count, the speed, and the radius. Okay, I will have a null and collapse selected. Okay, let's go inside here. Let's change this with an out as yeah, it's by default viewed by this base viewer. Okay, so yeah, it's first the ratio, it's 16:9. The count, let's go with 32, and the speed 2.625, and the radius, let's go with 1 divided by 64. Okay, and yeah, we good. Inside here I would like to have select and choose the resolution X and ratio, rename it resolution Y, and here a math with divide, and we have a merge here. Okay, like this. We also need a select for the count. Okay, we rename this into map. We use a math, and we go with the root and the ceiling. Okay, and since we will use feedback, let's have a keyboard in here. So when we press 1, we want to reset. Let's rename this into reset. Okay, like this. Now let's have a noise top, and this is 32 Rg. In this tutorial we'll work on 2D particles. So if we need 32 particles, we use this 6:6 resolution, okay, in order to get the starting position. But here we have 36, not 32, and the funniest way to solve this is using point repack 2 times. So 1, 2. Okay, first one is 32:1. If we connect this, okay, and the second one is map by map, and now we have 4 empty pixels marked with black. Okay, and this is the starting position, and for the particles we need a vector to always move that point for the next frame in whatever direction we want. So let's have a feedback here. Okay, and I will use the reset for the pulse, also for the reset. Okay, I will mark this black. And we want to add a force. And for this, we just take another noise, change the seed. As we like the directions for the movement to be in all the directions, actually, we go with the offset to 0. Let's have this amplitude to 1, like this. And if we add this here, and then because yeah, we need to take this add into a feedback, okay, but now the value would be so big because every time you add 1 maybe to a point, this one will go off the screen, and yeah, we can make it appearing on the other side, but yeah, anyway, this right here, it's very big. So let's use a mod, and in this mod we multiply with 1 divided by resolution X. So this means that the speed would be as much as traveling 1 pixels. Okay, obviously we can use a multiplier, and we will do that because this value will multiply with the speed. So let's drag the speed here, Control X, and yeah, multiply. Okay, now the value is it's good. Okay, and yeah, this is pretty much the core of a particle system. Okay, we have a vector, a force, which is added frame by frame. Okay, now let's use circle SOP to have some instances. Okay, and this circle has a resolution of 1. Okay, now we use transform here. Let me view this window. Okay, and in transform we go with radius. Okay, and now we use geometry. We go with instancing, and we drag this null. Let's rename this null actually in pose. Okay, let's mark it pink because we use this into geometry. So we drag it here and translate R and G. Okay, now let me split the screen, and I will split the screen top to bottom also. Okay, like this, and we go with geometry. Now if we press 1, we see the points are moving slowly. Okay, and I would like to have a render here, and for this let's have a camera. Okay, this camera, it's orthographic bottom left 1, and now render. Okay, we also need a material. We go with a constant, like this, and this render is 32 RGBA, okay, and let's see it here, not here, sorry, so okay. And as you notice, our points are not related to the size of this render. Okay, now let's fix this. So every time a particle will disappear from the right side, we'll bring it back in left side. For this we use a limit. Okay, and with this limit, because actually we need two of them, with this one we solve the x axis. Okay, let's loop here in between 0, 1. Okay, and I will mark this red as this goes only for the red, so let's mask the green. Okay, and I use another one. This one is red. I will mask the red instead. Okay, this one is green, sorry. Okay, and here in the limit we go from 0 to 1 divided by the ratio, so okay, like this. Now if we reset, yeah, we have them all here. They will not go outside. Okay. Now another thing is that I would like to have them on different radiuses. Okay, and for that I like to use again a noise. This time 32 mono. Okay, let's go with null, and yeah. This one is radius. Okay. Now this noise gives us the values in between 0, 1. If I offset to 1 and amplitude to 0, this is a constant 1. Okay, so I can use this. Let's make it pink. I can use this in scale and use red for all channels. All the channels. So now if I play with the amplitude, I can get different radiuses. Okay, so yeah, this is good. Let's go like this, and 1.256. Okay. Now in order to not have those 4 pixels, or depends on the count. Okay, you see here that the last 4 should be never used. Okay, it's much cleaner like this to actually see what's there. So I would like to go in this repack and let's see this as a color. Okay, now I will use a matte here. Okay, and then another output like this, and in this matte we want to mark with white the pixels that have the values, okay, and with black the empty pixels. And for this you can go with length, but you will make one operation which is not necessary required. And if you go with square add, okay, you mark the mask the alpha, and this should be 32 mono. And also here we go with ceiling, and now we use a limit to make sure this texture is either 0 or 1. So we clamp it like this. And now if we multiply, okay, they are the output are switched, doesn't matter. If we multiply like this, then the vector for the direction will have those pixels marked with 0. So yeah, this texture it's much cleaner. Now we can also multiply here like this, and you see the 4 circles in the corner bottom left, they disappear. Okay, so this is better. And now let's solve the trail first. Okay, so the trail it's quite easy. Let me put the radiuses all equal, and maybe 1 divided by no, this would be too much, 256. Okay, like this. And now let's go into palette, image filters. Let's grab feedback. Okay, now for this we use the reset. Okay, now let's increase this to 99. Okay, let's go inside here, and yeah, for this particular case we don't need the wet dry mix, and yeah, let me clean this a little bit, because we don't use it here. So what we do, we use this level, for which I suggest to take this clamp out. Okay, the ramp would be much more smooth and precise. And let's have here transform, with which we put the black background. Okay, now what if we want the colors, but we want the colors also some solid color, actually, not this ramp, and we can use threshold like this, and yeah, by changing this value we can change the trails length. Okay, and also by playing with soften, we can soften the tail, the end, much better. What if we want colors? If we want colors, we can easily use this 0.3 pack. Let's rename this to count, because yeah, this is what points we have. So here inside, let's take a look. So in count we have out points. Okay, so let's copy this, and in geometry for the colors, in count slash out points, we use R, G and B, and let's see. Okay, now I don't like what we have here. Okay, and I like to have more controls if sometimes I don't want a solid tail, or I want to change between ramp and solid and stuff like that. Then I will have this feedback only for the alpha. So let's have a reorder here like this. I'll take alpha, and this is mono plus alpha. Okay, let's reset So, and I can use the same feedback. Okay, and I can take 1 here for the opacity. And now, if I multiply those two, okay, so here I need a solid color, because actually let's give them different colors. We use a noise and we connect the second input. Let's have the resolution X and Y for the noise. So here it's Y, okay. This one is 32 RGB, like this. Okay, and let's see, we might have some ugly pixels, you see here, okay, and I believe, let me put this aside a little bit, okay, I believe it's from the anti-alias, okay. Now let's press 1, everything it's much clearer now, okay. And they are not moving the same speed. And why is this? This is because here in this noise, you see, we have the vectors from the origin to and the tip where we have the dots, and the length of them are different. Some vectors will move the particles longer than some other vectors, okay? In order to have them all equal, we need to normalize this texture. So, view as image, okay, let's have a null here, like this. I click outside and collapse selected, normalize. Okay. And here inside, we need a composite. Like this, with divide. And for the transform fixed layer, it's input 1, and also a matte in which we take the length of the vector. So, like this, we mask the alpha. The output is actually monochrome, so let's see that. Okay, and now let's see where we have the tips now. It's a circle, okay? So every vector, all the vectors are equal now, right? Okay, if we reset now, they all move with the same speed. What if we want to have them moving in a certain direction, okay? Let's for example only left, right, bottom, left. Let's do that, and for this we use another noise which is monochrome. Okay, let me have another null, and I want to build a folder. Okay, I name this angles. Okay, and yeah, let's update this reference with the map for the resolution. Okay, and now this noise has to be in between 0, 1. So let's move the offset to 0, 5. And now we use a limit. Okay. And this limit, we go in quantize and go for the floor, and the value step, it's 1 divided by 4. Okay. Now we use a mod, and we multiply everything with 2pi. So let's go with mod.pi multiply with 2. And from here, we use a function okay. I will make this red and take function r, take cosine, okay, with radians, and let's have this nearest pixels. Okay, copy paste. I'll have this green, and I'll go with cosine. It was, so now it's sine. Okay, and we use a reorder. We take the input 2 for the green, and this reorder should be RG. Okay, and nearest pixels. Okay. Now we don't need this null 2. What if now we connect these angles? Okay. Now you notice the particle goes only in 4 directions. Remember, we limit with quantize and stepping with 1 divided by 4. So we'll go back there in a moment, but now maybe it's not so interesting having the same exactly direction, okay? And I would like to noise this a little bit, so I will use a noise, for which I go with offset to 0 and amplitude. You notice we have 4 directions, okay? And if we connect to the first input in the noise, here we have some little bit different directions, okay? Now if we make this moving, like abs time dot frame divided by 256, let's see. Okay, they are slowly moving, you know, in a noisy manner, but they will always keep the direction. Remember, left, right, top, bottom. Okay, so yeah, and now by playing with this noise, you can get different output. Okay. Yeah. So if we let me check. Oh, yeah. I didn't saw the rampy tail. We set it here. Okay. So now we are solid, and yeah. Okay. So imagine if you want to make kind of a knitting or textile something, and you have I know much more particles like this, and obviously a smaller scale maybe. So yeah, it's pretty close. Okay, and now let's go down with a couple of them like this. And what happened if I will use the angles? Okay, so we are straight now, but I want to play this noise. So let's go here and say abs time dot frame divided by 5, 1, 2. You notice we get different directions all the time, and the new directions are also in 4, just 4, as we said. So by changing the speed here, going maybe slower, okay, you can get some crazy output. Okay, now what if we want 6 directions? We go here, 6, and reset. Okay, and now, yeah, anytime we can use this noisy addition, okay, with to the main direction. Okay, now, yeah, let's see. Okay, so now if we want to build a surface on each particles, we need a little bit of math. It's nothing difficult. We actually did it in maybe height maps tutorials I did before, but yeah, let's make it again. So for this I will go with yeah, yeah, like this, some bigger circles, and I don't necessarily want to see them in trail right now. Okay, okay. And I would also make a little variation for the radiuses. Okay, okay. Now we want to build kind of a igloo, okay, semi-sphere above each circle, and then we have the normals for the semi-sphere, and if we feedback that, we get some very nice surface for our snakes. Okay, and to do that we need to have 2 other buffers, let's say, but it's actually renders. Okay, and we need one with the same circles. Okay, but for the color one we need the radiuses, okay, embedded in that texture. Okay, so we will have little ramps for the circles. Okay, also we want to have the position for the circles, because right now we don't have the position. We start with the starting position, which was just noise. Okay, so for this I will go like, I will Control C, Control V this geo. Okay, in this render it only takes geo 1, and this one only takes geo 2. Okay, now, and another geo, and I use a render pass for the render 2 and takes the geometry 3 like this. Okay, so here in geo2 I will take as a color, I will take the position. Okay, now I have a texture like this, which actually means that I have the value for the center of each circle in a in a all the area of the circle is filled with that center color, okay? And it's very helpful when doing math with this technique. Also, we need to have the radiuses, okay? So I will grab this texture for the GO3 like this. Remember, the radius is much smaller than this, so we still need to multiply with this value, okay? But I'll go with this to better viewing what's happened, okay? And yeah, let's go here with the math, and we just multiply with this radius, okay, like this. And yeah, I believe I need to mask alpha. Yes. Okay. And now I would like to solve this normal map sphere inside of a folder. Okay, so I can use a remap, not a remap, a reorder, and I'll grab those two textures. So let's go input 2. I'll take input 2 for the blue. Okay. And this texture has to be 32 RGB. Let's go RGBA. Yeah. We'll see. And now we build, we insert a null, click outside, collapse selected, and I name this sphere. And yeah, luckily the output would be a normal map of a sphere. So in order to do that, now I will split again the center and the radius, right? So I'll go with the real. Maybe let's go. You know what? Let's go like this. So I will have two inputs. Okay, so let's go with another in. Okay. So yeah. And let's go inside. Okay. Now, in order to build a sphere, we need to have the distance, okay, to each point. Imagine we build a sphere here in my palm, okay, like this. So that means I need to raise all the values for the height map, okay, as high as they will touch the sphere here. So I need to have the radius for that sphere. The trick with rendering the circles with the radius would give us the radius, obviously, and yeah, the math is quite easy. So what we still need here, it's maybe, let me check. Okay, so I will use a select, and I don't have it here. So yeah, we need a UV. So let's have a UV. So I will go with this component, for which we go with okay, this, and resolution Y. Okay, exactly like this. And now I will subtract the UV from the center. So subtract Oh, we don't need to check the nearest pixels here. Okay, and now we don't see it. We don't see what's here. Sometimes it's difficult to work with a black texture. So, but we know there are some values. Okay, so we can always use normalize. Remember, we did one moments ago. So now you see what we have. Okay, so let me use a mod here, and I'll go with length. Let's go first with just length. Okay, and this should be 32 mono. Okay, and now we have some dirty white, which not white but a gradient coming from this UV. And what if we multiply this UV with let's select here with reorder. We just take the alpha. Okay, this should be mono. Okay, let's multiply like this, mono, or mono with transparency. Let's go with that. Not for this one, for this one. Okay. Yeah, nothing changed. So yeah, now we can't see here anything. Okay, but we have this not normalize. We have the limit. We have the limit now, and we go with normalize. So yeah, this is exactly what we need. So the distance from the center of each circle, you know, it's embedded in this texture, not really in this one, because this one it's normalized, but yeah, we have it here, and the formula is the height of the texture we need to find out for the sphere. It's root of radius square minus distance square. Okay, and right here we have distance. Okay, now to be more optimized when doing this, let's have here d square, because for this case we don't need actually the distance, only the distance squared. Okay, and instead of going with another math here and square it, okay, we can do something like this. So we go for the length. It's exactly like square, add, and root, and we take off the root. Okay, now this is distance square. Okay, and yeah, we need the radius square. So this is the radius. We use a mod, and yeah, we go with square. Okay, and now let's subtract this. Okay, and we need to make mod root of this subtraction. Okay, yeah, root, and again we will use the limit. Yeah, there are spheres. This is good. This is good. So now we have the height map. Okay, and everything is 0, but where we have circles, the values are very nice, round, and we can use that to add over the UV. So let's do that. Add over the UV like this, and we only add this for the blue. So let's mask like this. You can't see the blue. Let's make sure that this would give us the 32 RGB texture. That's, yeah, there are some blue there. And now we need to, because here we make use of something very nice, the surface, the normal map of a sphere is actually the radius vectors from the center to each point. So yeah, it's the same direction. And now we need to subtract not the UV, but the centers. So yeah, these centers. So subtract okay. Now maybe if we multiply this like that. Okay. So we can't see too well what's here, but I believe it's everything we need. And now the points on the sphere, we subtract the center out of them. So we have some vectors distributed where the surface is. Let's see. For this we take normalize and check this, and yeah, exactly what we need. Okay, now yeah, we have some transparencies which I'm not proud of. Okay, so yeah, we'll see how it works like this. Usually I don't necessarily go with transparency when I can compute it and take it out on the go, but in this case it's better to actually see what's going on, because with a black background here or in some other places, yeah, it's difficult to see. Now I wanna go with those normal spheres into a feedback, and I needed that transparency again. So let's go with the reorder, and I wanna use this for the alpha, not here, okay, here. So for the alpha I'll take input 2 and yeah, red, and we have this. It's very beautiful. So now we did a normal. Let's use a feedback here. The same for the colors. Okay, like this, and also multiply with this threshold. Okay, like this, and these are we need to or I want to move this into a tangent space, and so from here we use a mat, and let's rearrange this -1 to 1, -1 to 1, and here is -1 to 0. Okay. Yeah, maybe that transparency is not so bad. We'll see. And having this normal map, which is beautiful now, we can trick some shadows, shading. Actually, we don't trick it; it's embedded. So let's go with monochrome, like this, and we multiply now. Let's multiply with this threshold, okay, and use it like this. And yeah, we broke the line here, but let's go back. So yeah, these are the snakes that are moving in this case with 1 divided by 6, so 60 degrees angles, okay? And yeah, you can change that and do whatever you like. This file, a much cleaner version of this file actually, would be available for my patrons. And yeah, this was my tutorial. I really hope you like this. Thank you so much for watching, and you can support me on Patreon. There I'll have much more advanced tutorials for working with particles, and yeah, also particles will be the topic for the couple of the new tutorials that I will release. So thank you so much, and I want to thanks to all my patrons.